Okay, so let's start over. Um, as I was saying, so BricsCAD BIM is built on top of BricsCAD, which is well, it's actually all part of the same product, BricsCAD. Um, and what you're seeing right here is BricsCAD Pro, so it's a 2D version of BricsCAD, and it's very much similar to AutoCAD. So very familiar interface, all is very similar. The same command line interface, things like property panel, all these things, layers. It's all the same. But we've added some extra things on top that we think can make the life of users better and can make them more efficient. And it's mainly these things I'm going to show right now. So for the next 10 to 15 minutes, I will show some things in 2D that we developed on top of the standard AutoCAD functionality. And then after that, I will go to the more specific things. First thing I wanted to show you was the Drawing Explorer. So the Drawing Explorer is a location, it's a dialog box that shows us everything that's in a drawing in one location. So things like layers. Just a second. I think I'm gonna. Per, you have there's some noise in your end, so maybe if you can mute your side as well. So things like layers and layer states, dimension styles, all your block definitions, all these kinds of things are also located in this one location, this Drawing Explorer. So it's a very convenient tool that we think can save a lot of time. Another example of something that we developed that we think is a huge time saver is called the manipulator. The manipulator is basically a tool to move, copy, rotate, or mirror objects, either in 2D or 3D. And it's all with this one little widget here. You see I can move it, in this case, horizontally or vertically. But what you will see is when I move it, then you see I'm currently moving it by fixed increments of, in this case, 2 millimeters. So instead of moving it over 2.13652 millimeters, it's actually very, it's fixed increments. It's a very precise way of drawing. And when I zoom out, these increments become larger. So now I'm moving by increments of 50 millimeters, 10 centimeters, and so on. So this way you don't have to type in your values precisely, but you can click precisely using this adaptive snapping that we call it. Another tool that we developed that we think can be a huge time saver, it's especially useful for cleaning up drawings that have bad drawing practice. It's called Blockify. So I have here this drawing and it has very bad practice because you can see here, for instance, these two bicycles or these two bikes, they're actually the exact same, but they're just a group of lines and polylines. So it's instead of having this as block references, it's just a group of polylines. Just a second. But the good practice would be to have this as block references and block definitions. So Blockify can do this for us automatically. So if I click Blockify, I can take a selection set, like for instance this bike here. Click OK. And now it will scan the entire drawing where the exact same combination of these lines and polylines is found, and it will convert everything to block references. So you see now this is a block ref. But also this is a block ref. This is a block ref, and so on. So it's really cleaned up this drawing. Also here you can see there's just a jumble of lines and polylines here. If I just select some of them, you can see it's just a mess. But again, some of these bikes can be recognized here. So you can see, for instance, this bike here, it's also in here somewhere. So Blockify should recognize this. So I Blockify this bike here. We can see now also these bags found here. So Blockify is very useful to clean up your drawing. I'm just going through the rest of the drawing here to show you the end result. Okay. So now, by the way, so everything has turned red. That's just for demo purposes, just to make clear that everything are block references. That's of course up to the user how he wants to define these block references. But if I now go to my drawing explorer again, so what I showed you before, you can see here also that my block references are shown here. And you see here I have 4 new block definitions in my drawing. Each of these 4 is a bike. And you see for each block ref I have, in this case, 34 references, 27 references of this one, 29 and 41. So all of this was done automatically by Blockify, basically. So a very useful way to clean up your drawing. You'll also notice that this is a huge difference for performance and for file size. So currently the file size, so before doing Blockify, my file size is 5 megabytes, as you can see here. But if I now save this drawing, I'll just save it as another drawing here. And then go to my properties, I can now see it's only 196 kilobytes. So that's a factor of 25 times smaller in this case. Of course, it's an extreme case because basically the entire drawing consists out of block refs now. But even for less extreme cases, it will make a huge difference for file size and performance. Some other fun little tools that we developed are, for instance, copy guided, which allows us to copy objects along guide curves. So if I want to copy these few lines and polylines here, you see automatically it searches for these. What you see here, these blue arrows are guide curves that it looks for, and automatically it will snap to objects that are similar. So it makes it very easy to copy objects along certain curves or lines. Okay, so these were some small examples of tools in 2D that we developed that we think can make a difference for users. Now I'm going to switch to the more advanced stuff. So the stuff in this case actually that's part of the BIM workflow. So everything that I showed until now was part of BricsCAD Pro. What I'm showing from now on is going to be part of BricsCAD BIM. So that's a license level higher. But again, it's part of the same product. So it's just the same installer, the same product, just a different interface. I can switch between interfaces quite easily, actually. Currently, I'm in the BIM interface, or the BIM workspace, so to say. One of the things that I want to highlight before I start is that in BricsCAD BIM, you can use basically any kind of geometry you want and assign information to it. So you don't, like for example, in Revit, you're basically stuck with the families you have, or you can create families, but it's all very rigid. In BricsCAD BIM, it's way more flexible. You can model something from scratch or from a 2D layout, or you can import geometry and still reclassify objects manually if you want them. So just to give you an example, I will start by just some simple modeling. So I just have this simple 3D box here. It's just a solid and some lines and polylines on the bottom here. And I'm going to use a manipulator to rotate some of these faces. So I'm doing some basic push-pull modeling here. We want to create a very easy to learn way of working, kind of like SketchUp. To have a very push-pull kind of feel of this free-form modeling or direct modeling. But right now, so I'm not really thinking about my classifications, for instance. I'm just doing some modeling, so basically just some conceptual model. And then later on, we can add more information to it. So if I section through my building here, so this is a section plane that I activated right now. I can see currently this solid is just, yeah, it's not hollow, so I can make it hollow if I wish. And then I can start adding things like windows, for instance. Let's say I want to create a window here on this side. I can very easily do so. So this is just an example of just starting from a 3D box and sculpting my way to something that looks like a building. There's of course also other ways of modeling. For instance, let's say you have a 2D layout already. I have this very simple layout here of just some lines and polylines. Just a 2D DWG drawing. We can use a tool called Quick Draw to model over this. So I will just, you see when I open Quick Draw, a special cursor appears, and this cursor snaps to my existing objects. And it allows me to very easily create slabs and walls based on 2D or 3D geometry. You also see that the thickness of my cursor adapts to the lines here, so it kind of intelligently interprets these lines as walls, which makes it easier for me, of course, to model this building. I'm just copying some floors here. And just like this, you can already have the basis of your building. If I would section through it, so yeah, it already starts to look like a building. And this is just a few seconds starting from a 2D layout. Now, of course, this way of working starting from the 2D layout can also be combined with the 3D modeling that you saw earlier. So you can use hybrid methods. You can basically model whatever you want, just depending on what you want to achieve. You can use certain tools that make it easier or harder for you. Now let's say I have this building here, which was also made, it was the same building as this one here. But we manipulated a bit using some direct modeling tools. So I made my roof sloped. I added some windows based on some grids and so on. But actually, so far, this model is still just geometry. I didn't really think about the thickness of my walls, for instance, or the materials of my walls, the classifications. It's just geometry. You can also see this using the structure browser. So the structure browser, I didn't mention this before, but it's a very useful tool as well. It basically shows you everything that's in your drawing structured in a certain way. So for instance, in 2D, you could use this to sort on layers or filter on a certain entity type, for instance. Here in BIM, you can use it to sort on classification type, IFC classification, to sort on building and story, for instance. And you will see if I go to my classifications that currently in my drawing I have 64 solids and 14 block references. But there is no more information than that in my drawing. It's just geometry. If I take a look at, let's say, this roof here, and go to its properties, you can see it's just a 3D solid. There's some quantity properties, some mass properties, which I will have them stay class right now. So I want to assign more information to these objects. One way to do this is manually. So let's say I have this object here and this. So these two solids. we know just from seeing this building that this is a roof. These are roof objects. So what I can do is I can go to the BIM, classify manually, and then I can classify as any of these types of objects. So this is a hard-coded list of IFC types. In this case, we know it's a roof, so I will classify these objects as roofs. Now you will see here, actually, when I take this object, instead of just having a 3D solid here, we can now see it's a roof. There's some information like some quantities, some IFC properties that are currently not filled in right now, of course. They're just blank, but they're already there. We'll also see that now in the structure browser, instead of having them just as 3D solids, these objects have moved from entities to building elements. So now they're defined as building elements. We now see we have 2 roofs in our building. Now, obviously, we don't want to do this manually for every type of objects because that would take too much time. So that's why we created a tool called Bimify. And Bimify will basically, so it's based on machine learning. It will analyze our geometry and try to match classification types to the geometry. So we fed the system with thousands of drawings with correct classifications, and based on these drawings, it knows how to predict certain classification types based on geometry. So what Bimify will do is it will classify objects for us. It will also detect structural and steel profiles and match them to our library. We can choose to detect buildings and stories in this model, and we can choose to create some section planes as well automatically. So if I click OK, we will see in just a second that now, instead of just having solids and block references, we have 4 staircases, 5 slabs, 57 walls. If I isolate these walls, you can see it's done correctly, so it recognized everything correctly. Some windows, 2 roofs, and 18 rooms. So also these rooms were detected automatically by Bimify. So it detected the spaces inside solids and made rooms inside them. If I now restructure my structure browser, you can also see I have now 1 building. Inside this building we have 5 floors. So that's all correct. By the way, something I didn't mention before, I don't know if you noticed this, but this right here, so this cursor, this tool part of my cursor is called the quad. It's available also in 2D drafting, 3D modeling, BIM, and mechanical. It's workspace dependent, and it's a toolbar that appears at your cursor when you might need it. And it shows you tools that you might use at that moment. Also, it learns your behavior, so it tries to guess what you want to do in a certain situation and proposes these tools to you. So it's also a sort of artificial intelligence application to make you work faster with the product. Okay, so I classified all of these objects now using Bimify, but if I would say, for example, create a vertical section through my building here, you actually will now see that currently there might be a problem with my scaling. But actually, so all of these objects are currently just, again, 3D solids with information to it, but there's no materials yet. So what I can do is I can open my compositions library. And you see here, for instance, if I open composition, see this composition is made out of 4 materials, each having a certain thickness. You can of course make your own library, your own compositions as well. But I will now use some pre-made compositions. Like for instance, this one. You can just simply drag and drop it onto your objects. Now, it's hard to see right now because, yeah, so you should know I'm currently working on a sort of development version, and there's in the current development version there's something wrong with the scaling of these hatches. So you can see normally these hatches would be like 10 times or 20 times as large. So it's hard to see right now, but actually you should be able to see that there's different materials. It's a bit unfortunate. Maybe I can just quickly okay, that's better. So I fixed it temporarily. Now you can see that my materials, I have different materials applied to my different objects. So this wall now has 5 different plies. I can also enable my rendering materials so you can more clearly see what you already have assigned materials to. And I can do the same for these interior walls, for instance. Or for this roof. Now again, I don't want to do this manually for all of my different type of objects. So there's again some sort of artificial intelligence tool that allows us to copy these compositions to the rest of the drawing. So there's a tool called Auto Match right here, which will allow us to copy compositions and auto-complete this model based on the information we've already given to the model. So it will try to assign the correct information of materials to the other objects as well. And just like this, we have already some more information to our building yet. So we're gradually building up information in our model. But you can see there's still some things wrong with it. For example, if I were to zoom in here to, let's say, this connection here, obviously the connection of this detail between the wall and the slab is not correct. So we can fix this manually. I will do this now here manually in this one location. So I want to create the correct type of connection, which again I can do by direct modeling. So I can just, in this case, push-pull this one ply further away through the other object. Oops, sorry. So let's say this is the connection we want. So this is the correct connection. I now applied this connection to the entire length of this wall here. So over the length of this wall, this is already correct. But if I would take a look at the other side here, this back side, here it's still the incorrect connection. So again, I can automate the process of having this detail copied in the rest of the drawing. So there's a tool called Propagate. It's over here. And basically, Propagate allows us to take one detail, whether it's 2D or 3D, doesn't matter, and automatically or smartly copy this detail to the rest of the drawing. So I'm now selecting my detail. It will make a sort of 2D abstraction of this detail. And if I now click OK, it will scan the entire model where this detail can be applied. And now so it scanned the entire model, and you can see every location where it can be applied is now highlighted in green. So you can now see here each green check mark is a location where you can apply this detail. I can turn it off if I don't want it in a certain location. But in this case, I will just click OK and accept everything. And you'll see now that this connection has also been applied, for instance, here and here. So in the entire drawing, basically. Which is obviously very important for things like your quantity takeoffs, because now we have the exact quantities for everything. So like for the concrete of the slab, which has a different area than the tiling, you need to know this, of course. All of this information can be extracted, of course. Now in this case, I made this detail manually here in one location and then copied it over. It's also possible to save these details in the library and then apply them later on in other projects or whatever. So you can make up your own library of details. For instance, I have here in my library a detail for sort of wall roof connection. If I click it, you can see it here. So basically I want to apply this connection or this detail here to my model. So I have this extra roof cap here, I have this extra block here. So it makes new entities based on what's inside this detail. If I click propagate, again it will search the entire model where this detail can be applied. And you see it gives me, in this case, 7 possible locations. You already also see, for instance here, that there's a warning. This means if I apply this detail here, there will be an interference or a clash with existing geometry. And it highlights it here as well. So, if I click OK now, you will see that there will be a clash that we can then solve, of course. So yeah, I'm going to solve this now. Just like this. But now we have this correct detail here and here. And here. So that looks good. Okay. So this was an example of the workflow starting from 2D geometry or 2D layout, making a 3D model and adding more and more information until you get a higher level of detail. Now obviously you also want to extract this information in the form of plans and sections and schedules, bills of quantities, and so on. Now for this I'm going to use another data set here. It's actually the same building but part of a larger project on a larger site. To also show you that it's possible, so I don't know if we should go into detail here, but we also have tools for for site modeling or civil design. But what I want to show you with this project is that we can combine several drawings, separate drawings, in the form of XREFs into one project. So if I open my project browser here, I can create a project. In this case, so all of these drawings here are drawings that are in the same folder. But actually these ones here are already XREF'd in my main model. So maybe I'll show you more clearly using the XREF browser. So there's an attachment panel. In this case, so I have my main drawing, which is the master file, has all of these drawings as XREFs loaded in. So it's possible to, it's just the same technology as XREFs in AutoCAD, but it's extended so it works with BIM properties and with BIM models. And you can see when I have my structure browser, my project browser here, what I can see here is all of my section planes. So you see here these blue lines. These are the same kind of sections that we've been using earlier to just section through our building while modeling, for instance. These same section planes can be used to generate 2D plans and elevation sections, things like this. And they're listed here. Schedules, currently we have no schedules of this project. Sheets, so we already have some existing sheets of this project. Currently, you see they're updating, so these ones are up to date. This one is currently updating. These ones are out of date, so they're waiting to be updated. So you can choose to automatically update plans and sections in the background, or do it manually, like this, for instance. Now the way it works is these sections are generated on sheets, so the same technology of sheet sets is used as that you've been working with previously. So if you know sheet sets, you will know how to work with these kinds of with this technology. I'm just gonna drink some water because my voice is starting to crackle. Now I can see here that my generation of this one section takes quite long. I'm not sure what's going on. It shouldn't take this long. Yeah, something went wrong. But still, I can show you the results of some of these sections. So we have, if I open one of my sheets, this is a sheet with 4 floor plans of this building. And basically everything you see here on this drawing is done automatically, except for the dimensioning. So currently, dimensions still need to be placed manually, but all the rest is done automatically, like these tags. Everything you get from your 3D model is of course also shown here in your 2D drawing. So materials, things like this. Also things like your material, the colors, the representation, of course this can all be stored in templates. So it's fully customizable. Also the information that's shown in, for example, the tags. In this case we have this wall tag. It just shows wall type 3, but you can also show, for instance, your fire rating, your different materials, the thickness of your wall. It's all customizable. I'll just open another sheet here with some vertical sections on it. And so the way it works right now, currently, it's only possible to generate 2D drawings from your 3D model. And you can, so we use the 3D model as our one source of truth and generate our 2D drawings from there. So it's not possible to make changes here and have them reflected in our 3D model. However, we are working on a new technology as well that would allow you to sorry, I'm just going to close down Slack here. What was it? Okay, I was saying we're working on new technology that will allow you to work from your 2D. Yeah. Okay. Okay, that's good to hear. Where was I? Yeah, so it's also possible to create schedules and things like data extraction. So creating schedule is based on data extraction, which works the same as in AutoCAD. So you can extract any kind of information. You can extract information from your 2D drawings, just like lengths and the lines and the lengths of your line, for instance. But you can also extract quantities from your 3D model, like volumes of your concrete, a list of windows, for instance. All of that is also possible to be extracted. I'm just gonna, so what you see here now of these sheets here, This was pre-made, so we made this in advance as kind of a demo set, but it's also, I will show you how to make plans and sections from scratch. So I'll base it on this one model here. So if I open this model, just have to use my quad. You can see this model is also an XREF, so it's an external drawing XREF to this model here. But you will see currently there are no section planes available. So if I want to create, for example, plans of this model here, I can create a horizontal section like so, on a certain height. Well, actually what I'm going to do is I'm going to use Bimify to do it automatically for me. So if I click Bimify, you will see these blue lines. These section planes are now automatically created. One on each floor and also 4 elevations. And these four, so these new section planes are also now visible here in the project browser. So here and here, and then these 4 here. And you will see if I go to my sheet set setup, you can see actually all of the existing sheets that I already have in my setup. Which these ones already have a destination, so these ones are the ones I showed you before already. But you can see that there's some that don't have destination yet, so that's these new ones. So this floor 0, floor 1, these ones here, they haven't been in the sheet set before, so they don't have a destination yet. You can also see if I go to my sheets, I have a preview of 3 new sheets that will be created when I make these section planes. So in this case, I have one sheet with this one floor plan, one sheet with this floor plan, and then one sheet with these 4 elevations. This is based on a certain, so my template layout and a certain scale of my section plane. So if I take one section plane like this floor 0 here, the sheet has a certain scale. If I would change the scale to, let's say, 1/30, let's say, and go back to my sheets here, you will see my first sheet. Now it no longer fits on the sheet because it's already larger than my sheet itself. So I'll just turn it back to 150. Oh. Back to my sheets here. And create my sheets. Now you will see 3 more sheets have been added to my project browser here. If I open this sheet, currently you will see just one viewport, but it's going to be empty. That's because I haven't updated this floor plan yet. So if I can do it in the background or I can do it manually by clicking update and generate this floor plan for us. So everything you see here again is just done automatically. So your materials based on a certain template, your tags, things like this. You can do the same for this second floor here. And of course, if I make a change in my 3D model, these changes will be reflected here as well in this plan. Okay. So that's kind of an example of how you make these sheets based on your 3D model. We also have the sheet set manager. That's the same as in AutoCAD. I'm not very familiar with it myself. I don't use it that very often, but it's also here. So if you're used to using that, you can also use this one here instead of the project browser. Okay, I think this already gives you an idea of our general BIM workflow, how we work, starting from 3D modeling and creating some sheets and plans and things like this. We also have some tools for structural steel modeling, MEP modeling, things like this. Maybe I can show something of that as well. Maybe for structural steel modeling, I'll just give you a short demo. It's actually a video I'm playing now. But it should give you an idea of what's possible using our structural steel modeling tools. So again, we try to make it as easy as possible to model, try to make it very intuitive. We have a library of profiles in the software itself, but you can also import your own profiles as well. In this case, we're just shifting through our library here and taking a Russian standard and creating just some columns. So you can model these columns or these, what we call linear solids, as if you were just modeling lines in 3D. But there's already a profile attached to it immediately. So that's one way of modeling, is just drawing points in 3D space. Another way would be to start from a 2D line work and apply information to it. So in this case, we have some 2D lines and polylines. And we're just applying profile information to these lines. And we're generating a 3D model out of this directly. So you can see in red, displayed in red, are the axes of these objects. You can add eccentricities of these axes if you wish, which is something that's used very often in structural steel modeling. And you can add some, or you can create some very low level of detail connections. So in this case, currently, there's quite some clashes between my objects, so they're just running through each other. However, if I click Structural Connect, it will make a very low level of detail connection between all of my objects. So kind of just everything is now cut off properly. Now I'm just going to copy this truss over to my main model there. Okay, here I'm just copying some of these trusses, so this is just some basic 3D modeling again, just to finish this steel structure. Again, still in a quite low level of detail, but using the same technology as I showed you before, using the propagate tools, it's possible to create higher level of details of these connections, for instance. So I will show you later. I'm just finishing this structure here as well. But for instance, for the connection between these columns and these beams here, we have actually in our library, well, this library is empty when you install the software, but you can make your own library. And this is now a custom library for this project that we can apply this kind of connection to these details here. So this is one pre-defined or one saved detail in our library. And again, by clicking propagate or by just dragging and dropping this detail into our drawing, propagate will scan the entire model where we can apply this detail and show it automatically where we can do so. Same for the column beam connection here. And then for these smaller connections as well, some different type of connection. So again, using propagate, it's very easy to consistently have a higher level of detail throughout your entire model. Okay, so this was just a small example of some structural steel modeling tools that we offer. Now, we don't do any structural analysis, for instance. That's something we leave up to our third-party application developers. So we try to have our third-party application developers integrate with our software as much as possible. And that's why we, as a platform, try to provide the best type of generic tools like this Propagate, or like just a very good generic platform that our third-party application developers can then develop onto. For instance, there's this structural steel detailing software called Parabuild, which really integrates with our BIM APIs. For steel detailing, we also we're working on integrations with structural analysis packages, things like MEP or HVAC analysis, also things like rendering. Maybe I can give you an example of an integration that we did last year with a rendering tool called Enscape. So that's an integration that's already on the market, but we're also working on other integrations, like for example Unreal or Twinmotion, all these things. So we're really trying to create what do you call it, an ecosystem of third-party applications that really integrate well with our BIM software. So these applications can be found on our App Store, but since last year we also have something that we call the BricsCAD Collective, which is actually to promote the applications that are very well integrated. So for example, this Enscape product is very well integrated with BricsCAD BIM, so it's almost like one product if you use it. These kind of integrations, we try to promote this by having them be part of our collective. And we're still currently researching the best the best application developers that have the best integrated tools in each area of expertise. Also things like Grasshopper. Since last year we have an integration with Grasshopper as well, which allows you to create geometry in Grasshopper and bring it directly into BricsCAD BIM with a direct link. So you can have your conceptual modeling straight from your Grasshopper into your BIM model. Okay, waiting for this model here to open. So this is one model here that we made with BricsCAD BIM. And then using a tool like Enscape, you see it's just one button inside the BricsCAD interface itself. And it's used for real-time rendering, so it's very easy to create real-time renders based on your model, especially during the modeling or design phase. When there's still a lot of changes to your model, you can make the changes and see it instantly in your Enscape real-time render. Okay, performance is not the best because I'm currently recording as well and using WebEx, so there's a lot of things going on at once.
Yes, you're right.
You can see here, so this is a real-time render of this model. Yeah. And you see when I make changes in my 3D model, actually, for example, I just, let's say, activate this vertical section here. This change will also be directly reflected in my real-time render in Enscape. Okay. I'll just change the time of day because it's very dark. Very dark here, yeah. So this can be used to very quickly walk through your building, your model. And so it's this kind of integration that we really want to see, not only for rendering applications, but also for structural steel detailing or analysis of HVAC and all these kinds of things. So we're really counting on our partners to create really solid applications for each vertical market. Does that already answer part of your questions? I think it already gives you a good overview of what we offer. But then maybe now you can. Yeah. That's correct. So, okay, sure. So you mentioned the components library. So we have a library of components that we ship with the product. Um, it's fairly extensive, but of course, if you need your own components, you can always download it from online. So we support IFC, DWG, of course, because that's native, and also some basic RFA import, so we can import graphic families as well. Although the functionality of that is limited. And then about the MEP, so again, what we try to do is we try to provide a good basis, some good modeling tools that can be used by our third-party application developers to create solid MEP applications. For instance, if I go to my profiles library here, so we have the BIM profiles, different domains, so structural steel you already saw before, with some eye shapes, different standard like the American standard, European standard, all these kinds of things. But also, let's say piping with some predefined, so this is a standard library of pipe sizes that we again can just drag and drop into our drawing and start modeling with it. So I'll turn on my polar tracking here, my auto mode. So it's very straightforward to model with it, and you see automatically these bends are already created as well, so these flow fittings. And we have things like, for example, if I want to move this part of the pipe, obviously the other parts of the pipe move with it as well, so everything stays connected. So we try to again have this kind of basic functionality to work properly. If I rotate my pipe, the other ones stay connected as well. Or if I apply a different pipe size to, let's say, this one here, automatically a reducer will be created. Obviously, we can take this reducer and change its properties. Like this, for instance. So we try to make it very straightforward to model with these kinds of what we call linear solids. We also created some basic, I think what's called branching tools. So for example, we have this very simple layout of some flow terminals here, this main unit here, that we can connect using the flow connect tool. And automatically it creates already some sort of branching. Now this functionality is fairly new and it's still being developed, so it's still being improved. But what you see here is already available in the product. So you can choose between different layouts, fine-tune the layout a bit if you want. Say for example, I want to have it like this, or like this. You see, actually, I just connected these flow terminals automatically But you see already a certain diameter or pipe size or duct size that was already assigned. For example, here you have these round ducts. Okay. Yeah. So what are you seeing right now? Okay. Um, did you see the branching that I showed you? So the automatic routing of the ducts. Okay, yeah, okay, good. So, and the duct sizes that you see were actually saved inside these flow terminals. So each flow terminal has a flow connection point, and this flow connection point um, contains information about what type of duct or what size of duct should be connected. So that's how this information here was made in this 3D drawing. And then of course, if you still want to make changes, let's say I can make these two main branches smaller or more narrow as it progresses. So I'm cutting up these pipes here. And assigning smaller diameters to it. Okay. But again, for things like calculations, like volume calculations or flow calculations, again, we rely on our third-party application developer. So that's something we don't do ourselves. We just provide the basic modeling tools and the basic library so people can start working with it. So for the more vertical knowledge, we count on our third-party application developers. I think that's everything I can show for MEP or HVAC. I don't have very much prepared for this because it's also not my area of expertise. But there's also a part of it in the training. So if you wish, you can always go through the training and see what you can find there that's relevant for you to know more about. And then, of course, if you need more technical knowledge, you can always contact me or my colleagues directly. We can provide you with more information. Okay. Perfect. Yeah. Yeah. So currently, the workflow that we we propose is that you use also XREFs again for these different disciplines. So each discipline has their own XREF or set of XREFs that are then linked together. Um, we're also working on a more streamlined multi-user workflow for the next version. Um, however, it's currently it's too early in development to be able to show or see something of that. But for now, we propose a workflow of using XREFs. And then actually the coordination or collaboration, we use Brixis 24/7 for this. So I don't know if you're familiar with that. Yeah, 24/7. Yeah, yeah. Yeah. Okay, so I think I understand what you mean. You can get this information through tools like data extraction, so you can extract information about the walls in one or more XREFs inside your main model. However, not in model space, because in model space, again, it's the same as in AutoCAD, you just select the entire thing as one block. And that's also one of the reasons that we're working on a more streamlined way of working using multi-user, so a more streamlined multi-user workflow, where it's possible to have everything in one drawing, but you can check in or check out parts of drawings. So it's going to be a more flexible way of working than XREFs. Well, yeah, maybe I could try to show you. Um, if I would go to here. So currently, let's say, for example, maybe I'll go to this building here. So in this building, we have our architectural and our structural in two separate drawings. So our structural steel is one nested XREF actually.
Yes.
Okay. So you see actually in model space, if I select the structure, it's one block because that's the same as you would expect as an XREF.
Yes.
However, you can so you can extract information from it. So for example, I can select this one footing here or this footing here if you wish. And also, let's say in a structure browser, it's possible to, so that there's this option to explode XREFs in a tree. So this will mean that I will see all my separate objects, my steel structure. I know I have 30 beams on the floor zero, for example, or 20 columns. Even though they're part of this one XREF, it's still kind of exploded in this tree view. And also when you're extracting information, like using data extraction or scheduling, it's also possible to go inside these XREFs and extract this information. No, I didn't. No, it's still one XREF. But obviously, if I want to make changes, I cannot. So I have to go to my XREF itself and make changes there. Okay, perfect. Mhm. Well, that's actually kind of a technical question. But basically, so the objects that you see in your plans and sections, they're, yeah, it's kind of hard to explain here now during this presentation. But basically, automatically, based on a certain template, layers are created in your sheets that that have these different objects applied to them. And these layers have certain properties like your line type and lie weight, and these can be predefined. Um, but I suggest there's a certain section of the training that Pest sent you that explain this in quite a lot of detail. So I suggest that you take a look at that because it's going to be hard for me to explain this now in a short time. But it's possible to control. Yeah, yeah. 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 I'll give you. Yeah. I'll give you an example. For example, this one here. So first of all, like in AutoCAD, also attribute definitions are also possible in BricsCAD, of course. But for BIM, we use a different approach. Um, yeah, I should have shown it to you during the demo earlier, but I forgot about it. So I'm going to show you now. I'm just opening a different drawing here. So basically what you can do is you can create property sets, custom property sets that are applied to certain types of objects. This drawing takes a while. Actually, do you mind if I take a 2-minute break? I might have to go to the bathroom real quick, if that's okay. Sorry, I'm back. Okay. So I was going to show you these custom properties. So you have our model here. So everything in this model has already been classified properly, I think. So like these windows, for instance. So we can assign custom properties to objects. So there's this thing called the properties dialog, custom properties. So we have some predefined properties like the like the basic IFC properties. So these are hard-coded and straight from the standard of Smart Build. You can also make your own property sets. So let's say I make a custom property set. Custom properties Windows, for instance, and assign them only to Windows. So like so. And inside this set, we can add properties. For instance, the cost, like integer or real, for instance, and manufacturer. So if I now click OK, if I just select any window in my drawing, I should be able to see this information in the properties panel. So there should be now a new property set. Yeah, here, so custom properties windows, you can see it here. We can add information like this window costs 2,000 euros, for instance. And the manufacturer is Windows Bricks. So I've added this information to this one window now. If I would now export this to IFC, I'll just export the entire model. So we can choose, by the way, IFC 2x3 or IFC 4. We support both. Takes a couple of seconds. Okay. If I now open this IFC file, for example, with Solibri, I should be able to see this information also there in the window. So all the information that we add ourselves will also be exported automatically. Oh, do I have to? Sorry, my Solibri is out of date apparently. So I'll use another application. Sorry? Yeah. Yeah. Exactly. Yeah. If I would have known, yeah, but okay, so other application, I think it was this window here. I should now have, yeah, so there's this new custom property set here, and it has this information, the cost and manufacturer. So yeah, everything that you add of custom properties to any kind of object can be also exported to IFC. I don't have experience with it personally. Maybe Park has, but I don't. Is it the 5D? I know we're working on things like phasing as well. Yeah, yeah. Yeah, yeah, it's something we're also looking into, but I don't know what the status is of that, so I'm not sure uh, how it works will work exactly. Yeah. Yeah. Well, maybe I should first explain the limitations of our Revit family import. So, um, yeah, yeah, yeah. So, our Revit family import currently only imports geometry, and I don't think it imports the geometric constraints. So, for example, if you have, let's say, a window that has certain widths, you can only bring in the geometry of the window, but you cannot change the width of it. Um, oh yeah, I'm not showing anything right now. I'm just explaining. Well, in terms of information, probably yes, but in terms of geometry, it's risky because you tend to lose information when using IFC. So I wouldn't recommend it. But actually, I'm gonna try something. So I do have somewhere a folder here where I have um, some Revit families. Just a second. So, so I have this folder here. I will show it with some Revit families in it. For example, so this custom door here. Um, let's say I draw a simple wall, and I have here in this folder, so I can simply drag and drop this. This is a RFA file. I can drag and drop it into my drawing and use it as a component, as if it were part of our component library, just like this, for instance. You see the geometry is there. It's also seen as a door. If I go to the properties, um, I cannot choose to change the width, for example. It's nothing I can manage myself. However, this is actually quite cool. Um, it's quite easy to turn this into geometrically constrained objects ourselves. So let's say I just created a copy of this door. I'm going to save it as a custom, let's say, custom door. Now it's turned into a DWG. And I can make this actually parametric. So 3D constraints and parameters is also something advanced and something mainly used in mechanical context. This can also be used, for example, for components. Like for instance, I can choose to manually constrain this object, or I can do it automatically. So currently, I'm automatically constraining this entire door object. And it creates all of these constraints for me. So you can see it now here in the mechanical browser, which means if I take a look at this length x, for example, the length in the x direction, if I animate this, you will see it changes the width of my door. So I can uh, sorry. Sorry? Yeah, yeah. Yeah. So this way it's possible to bring in your own standards of RFA, but again, there's limitations. Well, actually, as far as I know, we're also improving the RFA import functionality, but we're dependent on the developments of the Open Design Alliance. So the ODA is are reverse engineering the RFA and RVT file formats, and we're using that information to be able to import our own versions of RFA. So yeah, it's something we're working on, but it's limited.